chair for the next session, which is Realizing the Future Together. Heidrun Aam.
Hello everybody, my name is Heidrun Aam and I'm leading the work group for responsible research innovation in DigitalLife. I will chair this session on Realizing the Future Together, and please welcome our first speaker, Associate Professor Rahmi Lale. Rahmi is working at the Department for Biotechnology and Food Technology at NTNU. He's mainly working with synthetic biology, but today he will actually talk about communicating science in the digital life age. Please welcome.
All right, thank you very much for the organization committee for giving me the opportunity to present what I'm going to present today. Well, cool, this is working. So my name is Rahmi Lale. I'm the person standing between you and your lunch. I'll do my job hopefully very quickly. So just a bit of background. So I work as actually Associate Professor 2/Researcher at the Department of Biotechnology, NTNU, that is in Trondheim. For those who do not know, so it's myself and my colleague Martin. We are two PIs managing the lab. We work on different things. The main source of income is the Research Council of Norway, European Union, and we have local funding from NTNU as well in several grants. So things that we do photosynthesis research, we do synthetic biology, we work in nanowires like iron acquisition in bacteria, we work with microfluidics, and we also hosting actually the NTNU's robotic open source, I must insist, infrastructure, and several details can be found on our website. So, despite the fact that I am doing molecular biology research, in today's presentations I'm going to talk about completely different. But before I do that one, I don't know what the audience is, but we have an open position. I don't know if anybody is candidate. I don't think that anybody would like to take a PhD in this auditorium, but at least if you spread the news, I would appreciate that. Yes, so as I mentioned, I'm not going to talk about molecular biology per se. I'll talk about how we deal with the information that we generate and how do we disseminate this. So again, I don't know this audience, so I would like to start by asking a question. Is there a reproducibility crisis in science? So can I just see hands? Do you think that there is a crisis in science? Right, so, and who thinks that there is no crisis in science? Oh, Gunnar is one. And who thinks that they don't know? You don't know. All right, so seems to be a bit heavy on those agreeing that actually indeed there is a crisis. So to help you out now, representing what is not in this only in this auditorium, but also the researchers actively doing this research. So Nature published last 2016, I think one of the latest issues of the year, on a news article on research and a crisis in terms of reproducibility. So they have surveyed 1,576 active researchers from various fields, and they asked the question, do you think that there is a reproducibility crisis in science? And then the answer was 7% said they don't know. And 3% says, no, there is no crisis, everything is good. And then 38% says, yes, but there is a slight crisis, I don't know what that means. And 52%, so that practically, I didn't count the hands, but may represent the auditorium here, that 52% thinks that there is a significant crisis in terms of reproducibility. So if we, now this is just a fact, but what does it mean? Where does the data come from? So if we go in the numbers, one of the critical questions was as well that, have you failed to reproduce an experiment? So may I ask the audience as well, how many of you failed to reproduce an experiment that you didn't generate? Let's say based on read articles. All right, so how often did you fail to reproduce your own results? Right, so there is honesty there, but nevertheless, no one's seen who has raised their hands. So let's look at it, what the paper says. So they have breaking down to two. They asked, have you failed to reproduce an experiment that you read and you want to reproduce based on a publication or maybe your own research? And then the outcome is like this. So they have asked people from chemistry, biology, physics and engineering, medicine, earth and environment, and many others. And this is the sum. And this is the figure for chemistry. Chemistry people says that they have trouble reproducing more than 80% of the data that belongs to someone else. So what is science if you can't do reproduction? What is science if you're generating an information that has no reproducibility? And look at the figure for their own data. This is on more than 60%. This is, they generated the data on their own lab, and they can't reproduce it. And a further breakdown, of course, of biology maybe is more relevant for this auditorium, but the picture does not look really bright there either. And it's the same for the rest. So overall conclusion is we have a crisis, and the reason for the crisis is that we can't reproduce things put aside on somebody else generated, things that you generated yourself. So how do we move in a world where we are keen on doing research, but at the end we can't reproduce things that we have been generated or somebody else generated? So in 2014 I was really surprised to read this editorial note. I'm sorry for the lengthy text, but you can read yourself as well. And I would like to stress that Nature Methods is one of those journals where they publish methods, right? So the methods are at the core of reproduction, because if you don't know the method, you can't even start reproducing anything. And they conclude with this phrase: an open implementation that supports reproducible research not only provides confidence in the performance of a method, but increases the likelihood that other researchers can use and build upon it. It's a good statement, but just take a second to reflect on that this is published in 2014 from on a journal where they publish methods. They say, hey, having a reproducible result may be not that bad after all. And I find it really surprising, and I mean, it's just, this is just another statement to see how severe the condition or situation is. Maybe it's really not necessary to go through what is the model of scientific research that is hypothesis-driven. Well, we all know that we generate and specify hypotheses, we design studies, we construct, study and collect data, analyze the data, test hypotheses, interpret results, and publish and or conduct next experiments. And this is an iterative cycle that you all probably have been through. Nothing new about it. But what is new about it is, where do we fail? We fail threats to reproducible science. And these are, in the generation and specifying hypotheses, we fail to do control for bias. We do fail on low statistical power. We fail on poor quality control, p-hacking, that's the quite famous one, and publication bias. We need to publish, otherwise we will perish. So there is quite a bit of pressure there. And there's a new term, if you haven't heard, which I really like, it sounds nice, harking, and it is, you change your hypothesis after you know your results, and that is the bias. But in overall, the trouble is there is a lack of data sharing. We have to give the data out, allowing others to come to the same conclusion as ours. We can't just provide an information that is funded by the taxpayers, and we can't sit on that information only ourselves. We have to give that information away. Now, some of you may wonder, what about IP rights and so on? That's fine. The question is, when you want to release this information to the judgment that you will be making, if you're applying for a patent and etc., you may wait until everything is done and everything is finished and filed, then you can get your data out. But we have to get the data out. So this is a phrase that I have taken from John Claerbout, and he published this in '92. He already talks about this. Of course, he is a geophysicist, but he also incorporated, he's famous for putting computational science on seismic measurements and etc. But so it may not apply to molecular biology, but you may just change the computational science and put your field in it. So it reads, an article about computational science in a scientific publication is not the scholarship itself, but it is merely advertising of the scholarship. So if you publish a paper, you're just advertising something if you don't give the information behind it. And it says, so actually the actual scholarship is not about publishing the paper, it's about telling how did you generate those figures. Where is that data? Can I go and read the data myself? Can I find out what you did? And for those who know who Linus Torvald is, the guy is behind Linux kernel, single-handedly still operates it, and it says, talk is cheap, show me the code. It's kind of, I like the phrase. So all this open-ended talk now, at the end, what is open science? So why do I come to open science? So if we want to progress in the field of scientific research, we have to get the information out. And the information is on many levels. So one of the reasons that kind of motivate me towards giving this speech is in our lab, if you visit our website, you will see that we practice open science. We are not there yet where we want to come, but we are trying to practice and put these principles in our research. So then I need to define what open science is. Open science is the movement to make scientific research, data, and dissemination accessible to all interested parties based on three principles: transparency, universal accessibility, and finally, reproducibility. So, I would like to stress the point on transparency, universal accessibility, and reproducibility. So you might think transparency is a scientific ideal, and adding an openness to it when it should be redundant. However, the fact is, as I just mentioned, science often lacks openness. We do publish papers. These papers are put on behind paywalls. You can't get to the information. This is just one part of them. Getting information is one thing, it's just what you have written, but getting information on the information that you generated to write that paper, that is not accessible at all. So something has to change. So therefore, we are promoting the open research culture. So what do we mean by that? So in Frame Program 7, European Union program, project was on FOSTER, so it's called FOSTER, Facilitate Open Science Training for European Research. And they have came up with this, if you will, the open science taxonomy, sorry for the font size. And it's pretty detailed. So if you're interested, have a look at it. This is the open science taxonomy. So how you want to implement this open science aspect into your research is really up to you. There are different ways that you could do it. Given that this is a short presentation, I would just like to mention in practices that we are doing in our lab. So we do try to implement open methodology. We are for open source, open data, open access. So when I talk to people, like I say, we're doing open science, and they say, like, yeah, so you're publishing open access. Yes, but it is not all. There are many more parameters to it. And other thing is open peer review and open educational resources. So I can't go through these things on how do we implement them, but I would like to stress out one point about peer review. And I believe many of you are also peer reviewing papers. I am firm believe that the peer review should be open. So that means we have to be able to relieve our names, telling that I have reviewed the paper. And also we should prioritize the point that we should be going for open access journals. So something that I do, which actually makes my life quite a bit easier too, when a journal approaches me and asks, would you like to review this paper? I say, I have three principles. Are you open? And if you're open, are you allowing the reviewer's name to relieve itself? And overall, and also, do you have any compensation for my work? Because these companies, business establishments actually, there's a billion-dollar industry. So I don't want to give the names, but two most established publishing groups, they make $1 billion. And did you know that, and this is open information actually, you can go and visit one of those big publishers on the website, the profit range is 30%. If you're paying €1,000 for a publication, €300 goes in someone's pocket. And I think this is irresponsible. And I think we have to move away from generating the data, giving someone else the right to own it, and then we have to pay for getting access to the information as well, which we generated. I think this is just the tragedy, the theater of the tragedy. So I think this is a dramatic picture that something has to be tackled. But nevertheless, so if I have to sum it up, given the short time that I have, if science is going to provide the future, we have to be better at distributing the information faster. I didn't even go into the ways how we could do that, but nevertheless, in a transparent fashion and in such a way that this information can be reproduced. And we firmly believe that open science will accelerate this distribution. And I firmly believe that the future is in openness. So with that, I would like to thank you. This is our website if you're interested to look at it, especially if any PhD candidate is that you may target towards us, and my personal website at the University of NTNU. Thank you for your attention.
Thank you very much, Rahmi, for a very interesting and thought-provoking talk. I guess there are a few questions, and we can take a couple of them before lunch. Gaute.
Well, I think this is an extremely important subject, and of course, if it's not reproducible, it's not science. And so I think, but how do we change it? And I think an important thing is simply that the seniors of us who are deciding who gets grants and who gets positions should then just have to look at things differently and not just look at whatever age factors and all these impact factors, but just look at these things. How much of these people sort of actually contribute to the community by doing open science, open code, and so on. I think until we do that, it will be very difficult for the young people to sort of start playing by some more idealistic rules. So I think that maybe we should sort of start, when next time we advertise a position, say that, well, preference will be given to candidates sort of published in open access journals, for example. We could do things like that.
Do you want to comment on this?
Well, yeah, so how you want to implement that one is really different. So if you have, where did I have that? Here. If you were to see, if you could look at this paper where they have published it, so they have another figure showing what are the possible solutions that you could do. I think one of the top ones that scores high is the role on the PI. So the PI has to implement these regulations in the lab, and a PhD coming in will have no right to say yes or no. The trouble is, I mean, as you all know, that these informations are lying in our Excel sheets, and when you're done with you have the papers, fine, but papers is just a fraction of the result that you generate actually. So there is a cultural change that is needed, but of course there's also the funding agencies has to be pressing this high. What is your data management? One good example in a psychology journal, I think that one of the established journals in the field, they said that the data has to be open and openly available. So they made it a part of the submission process. And all of a sudden, all the attitude changed. Because if you're in such a position, you say, I will not publish your studies if you don't follow my guidelines, and voila. In a really short while, in 2 years, they could immediately see the effect of it. The data was becoming available. So it's not just boils down to us who are doing the research, but it's also responsibility, if you will, for example, the Center or the Research Council of Norway or EU is already implementing these data managements. So we have to take the action. And if you think about it, John Clearbaut mentioned that one in '92, and this is where we are today.
Can I take one more question before lunch? Yeah.
Okay, thanks a lot for your presentation and for opening up these topics. I'm not coming out of the field of biology, and I will be the talk after lunch. So, but what I was asking myself, even if you would make the data open, which I do fully agree with whatever you kind of argued, I'm wondering if the way how we structure our time in research, so how fast we have to decide on projects, how fast we have to decide on publications, etc., if that will fundamentally change the problem of reproducibility if you just make the data openly available. Because it's also the quality of the data that is made openly available and the time we need to prepare prepare them in a way that they become readable to a wider community. So who will pay for that, and who will give this time to the system to work differently? While we always talk about competition and more and faster and counting and accounting and whatsoever. So I'm wondering your thoughts about that.
Yes, well, the thing is, we have an implementation in our lab. We try to do on the master student level, push them, make them actually write up their results while they're generating it. Because one of the time-consuming aspect of it, and you will all agree, or I'm almost certain, we are never efficient when we are dealing with a mountain of data and starting to write it. That's the wrong way of doing it. Of course, it's not that's inefficient then. But for example, if I take a student and say that student has to use this platform to generate the information, and when you publish there, you just link it, done. Actually, there are really clever, I mean, I don't mean that it will solve all the problem. Yes, this is an additional load. But additional load it is because of the given understanding we have how we're managing the data. Then it is additional load because you feel as if I have to save my Excel sheet and then handle the data somewhere else. Yes, with that line of thought, it is a cumbersome process, but that has to change. We got to drop using the Microsoft Office for that matter anyways, but I'm tired of getting DNA sequences in a Word file. That still happened. No offense. So that means we have to handle that one differently. If you consider the current standards, implementation is tough. Yes, additional time is needed. Therefore, mind has to change. You have to edit your information in some better platform rather than first do your cumbersome process and then transform the information. No. We have to change the way we're handling the data.
Thank you very much, Rahmi, and a little thank you from the organizers.
Thank you very much.
We continue with the session on realizing the future together. The slot after lunch is not the most favorable slot for speakers, but I'm not worried that the next speaker will not manage to wake you up and keep you awake, because I've heard her talk before. Professor Ulrike is from the University of Vienna. She studied physics, but then changed and devoted her career to the field of science and technology studies, and has since then been a very significant and inspiring scholar to the field. She's also head of a new research platform on responsible research innovation academic practices in Vienna, and is also the Dean of the Faculty of Social Sciences in Vienna. So we are very grateful that Ulrike said yes to being part of the Scientific Advisory Board of DigitalLife and to talk to us today. She will talk about on the value of thinking and realizing our future. Welcome, Ulrike.
So I don't need that. Good. So good afternoon. I hope I can get between you and the envy to sleep after this very light Norwegian lunch. As I was told, they just have 2 slices of bread yesterday evening, somebody told me. And I know how it is about myth in society. So this myth has, when I turned the corner to the food station, definitely been wiped out. And I will go back to Vienna and say, Viennese food habits are just nothing against what the Norwegians do. Okay, so the title of my talk actually is slightly longer. It's called Collective Experimentation on the Value of Thinking and Realizing Our Future Together. And as Heidrun has already pointed out, and thanks a lot for the kind introductory words, I am heading a platform together with life scientists at the University of Vienna, which is called Responsible Research and Innovation in Academic Practice. And in academic practice, for that reason, that I would like to understand together with them what is the place and the possibilities researchers have nowadays to engage with reflection beyond what they have to achieve in their fields. And I think this is a really important question, and I will kind of touch on a couple of minor issues with this in this regard. So actually science is under societal scrutiny. Maybe this is particularly true for the life sciences, as the life sciences touch on the core of our understanding of bodies, life, and nature, and therefore the worries about what can happen in these areas is particularly highlighted. Now, when it comes to the talk before lunch, of course, evidently then the question of how can we rely on all these things, and are they reproducible, and can we believe in that, becomes an interesting question. But that's not what I would like to talk to you about today. Actually, we could ask ourselves in what kind of society are we living? Because when you want to do responsible research and innovation, you have to have some imagination about this other side under apostrophes. So what is the society? How do we think in it? I think it's an interesting overlap of two kinds of imaginations of society. The one side, we have an innovation society where the new and discourses on emerging technosciences, so a mixture of technology and scientific knowledge, are at the core, and the aim is then to create an innovation-friendly climate and to avoid public opposition to the kinds of things researchers would like to do. And on the other hand, I would say we live in a self-experimental society. And I take here a quote from Cross and Krohn: social practices increasingly present themselves as experiments. And they're experiments because they are willing to remain open for new kinds of experiences. So whenever we engage as a society to take up new kinds of technologies or new kinds of scientific knowledge, we cannot, and that will be one of the key arguments, fully know what that will mean on a long term. So what does that then mean for responsibility if we cannot really kind of do this predictive work? So two related questions here. The first is, what are the collectives, and by collectives I mean citizens, publics, affected groups, patients, consumers, or whatever this group is, related to or affected by innovations/experiments. And the second point is, where are the spatial arrangements? So where are the zones, the areas in which these innovations and experimentation happen? And how do we imagine developments accordingly? So if you would, just to give you a minor example, if we go and want to develop pharmaceuticals and then we go and test it in Africa, it is definitely to all of us clear that it will not profit Africa if we get good medication, but it will first of all profit the industrialized Western world. And then it will maybe, under certain circumstances and price politics and other things, will then go to the places where that has been tested. So we have to think about these kinds of two things. Now, we have brought in this responsible research and innovation discourse, particularly in Europe, but also in the US. And of course, that had forerunners like ethical, legal, and societal aspects and other things we have been tackling with. So what is here the core is we want to address societal needs, values, and concerns in some way or another. We want to care for, and this notion of care is really, I want to take it in the sense of the word. We want to care for the embedding of new scientific and technological developments. And we want to look at research and technological developments towards, and open it up towards societal deliberation and negotiation concerning relevant issues. So we want to look about what are matters of concern in contemporary societies. And you will see in a couple of examples how I will use that. Now, in the literature, there has been a debate trying to spell out what responsible research and innovation might be. And I won't take too much time because I want to come to one point of that. That's all I can cover today. And they underlined we need to think in terms of anticipation, so working towards what goals, implications of one's research, etc., inclusiveness, so sensibilities towards specific societal groups, reflectivity, here we are with the integrity and value question we already had touched in the last talk, and it's about responsiveness, so a realistic assessment of limits of what we can do, which is a difficult thing, because we like to not see the limits. But what I think is even more important, which is very often left out, we also have a responsibility for the whole set of knowledges we produce. And I would like to bring in a thought that comes out from ecology and that speaks, and to speak of a knowledge ecology. So we would have to think also, is the knowledge we are producing the right kinds of knowledge, which will help us to go beyond the now and to think things in a long term, while I do think one of the problems the last talk showed is actually that we very much go for the short term, where we can have impacts and publications and money and other things. And so the question, like, will we still have in a couple of decades enough knowledge to do the things we will need to do will be an issue. But I will not be able to touch on that today. This is just a thought which I would like to kind of keep alive and kind of continue thinking about it. Now, in one of the brochures I read about Digital Life, it says something like it's about it's being mindful of its societal context and develop anticipatory competence regarding its impacts. And I would like to pick on this notion of anticipatory and anticipation, and that's what I would like to speak about. So how do we do that? Actually, there's increasing attention devoted to anticipating, transforming, and or controlling technoscientific futures. We would like to have an idea where we go with what kinds of money we spend. And is that a future that is okay, and for whom? So simultaneously, we know, and we would always claim, that the process of research is tied to uncertainty and openness, to serendipity. Whenever I did interviews with researchers, they would underline and stress that. So how do these things go together? That we should know where we go, and that we hope for that the process is open and has surprises in it. And anticipation is also a very important political strategic role, because actually it helps us argue and justify technoscientific choices. Not only you, but also other researchers, right? These wonderful things when they apply for project money, how they will change the world, and we are have become very good and literate at that. So we argue for choices. So it's about implementing accounting processes. So we want to become responsible for the things, the choices we do, but it also, in an interesting way, requests some support and compliance from citizens. There is a lot of talk about if we don't do that now, we will be lagging behind X, Y, Z, and therefore we have to do that now. We don't have time to discuss. We don't have time to wait. We have to do it now. So the future, or I would say the futures in the plural, as it's an open and uncertain process, have become key actors in the way science and technological development are actually governed. Now, whenever we speak about the future potential of science and technology, we cannot get rid of the fact that we always also speak about a potential future. So one cannot never buy out of that. Whenever we develop something new, we also change the world. We impact on it. And I think in today's morning, somebody used something similar to Peter Drucker's management is doing things right and leadership is doing the right things. And I would like to get rid of the management and the leadership differentiation and say doing things right and doing the right things means asking what is the right and for whom is it the right. And if I'm in a company, the right is that my company makes more money and has nice working conditions. But what is the right if it comes to society in combination with science and technology? And that's a much more difficult question to answer. I might know what the right is for my team. I might not necessarily so easily be able to answer what the right is in a wider sense. So we need to understand the conditions of and different practices of anticipation, the ones we use in our everyday contexts. They play a pivotal role in recreating power relations and in organizing and ordering contemporary societies. So the way we understand our societies depends very much how we know about it. Just think about whenever you get into genetic classification things and when you can identify something not working the way it should, this means something in the real world if it's kind of tangible. So it needs reflecting the moments, so the when, the processes, the how, the places, the where, and the actors, the who that is involved in these practices. Now, I will touch very shortly on 4 forms of anticipation, which you will very quickly recognize how we deal with it. Envisioning and imagining and projecting, on promising, on time achievement, so until then we should have, and in performing risk and uncertainty assessments. And for each I will give you a short example and then come to a conclusion. Now, the most recent kind of let me say, outcry, debate, whatever you want to call it, around gene editing is actually a very nice case to understand what we mean by what might be the problem. And this is just a collage of very different ways of how society looked at these things. But the more important part, so it's opening, envisioning is very important in the sense as it opens up our imagination of where we can go and what we could do. But it does also, as you will see, create some frightening visions of what could be done. And that is actually the interesting question, like the can and the should. So what can we do and what should we do becomes suddenly a very important question. So of course, as researchers, we want to know what we can do. We are very keen to know how we can try out things, understand them, make them work. But the question is like, does that mean equal should do in a wider context? That is something that is really important. And so I find that cover from The Wired quite interesting because it starts with no hunger, no pollution, no disease. And I will come back to the rest at the end because I think it's precisely about that. So it's envisioning a world that we can perfectionate in interesting ways. And of course we all know that it will not be so perfect because we quickly realize that things don't work as on paper, but nature strikes back. But it's this kind of idea where we would like to go forward. And that has been driving much of the sciences around nature for the last hundreds of years, actually. Now, promises are a different genre. And so the most famous promise that has lived since 50 years is the so-called war on cancer. And so actually every decade had a different imagination how this war on cancer would have to be fought, how much money should go into it, etc., etc. More recently, I realized that in policy documents we have slightly shifted our language. We now speak of living with cancer, which I find really interesting as a move to go away from this war on, let's wipe it out, to okay, let's think about how we can arrange ourselves with cancer in new and innovative ways. But it's all this kind of bioeconomy thing. You see these elderly people made out of, so the pharmaceuticalization of elderly life in particular, where everything that doesn't work gets repaired by some medication. You have the idea of linking all the data or this whole big data business. That's a huge promise machinery where we don't know what actually will be the outcome of this promise. And in many ways, in the pharmaceutical area, we are rowing back already partly because we think that the promise might have been a bit too far. Now, in some of my work, I've been calling that an economy of promise. Why an economy? Because actually different fields of research battle over public attention and public money with different kinds of attractive promises. So it becomes a kind of parallel market of who can produce a more convincing promise to a society. And the bioeconomy promise is a very interesting one, which came up much later when the war on cancer and all that stuff was already a bit used. We come now with the bioeconomy and say our economy has to live on that, and if we want to be economically powerful, we need to invest in certain areas. So just think about what are we promising. And every project proposal has a wonderful part on promises. I've been looking through many, many, many over my life, and that is a really interesting genre of, and do we take responsibility for these promises? Not necessarily. Most of my friends in the life sciences make wonderful jokes about them and say something if in sentence 5 you have not said, I will cure X, Y, Z, this will not be continued reading anymore. So there is a kind of cynicism about this kind of promising. Then I find it interesting, it's these achievements in a certain amount of time. We live in what I would like to call a countdown society, where we have over the last 20 years created all these deadlines until when we will have to solve what. And this is a kind of different idea of anticipation. So time reduces and forces me to act now, because otherwise it's too late. So safety of nutrition in 2050, Energy Road 2050, I mean Horizon 2020, I don't need to tell you anything. And don't forget Europe 2010, if there would not have been a financial crisis, which is totally coming from Mars or whatever, that we would have achieved to be the most powerful knowledge economy of the world. I'm sure of that. But I'm sure of that, just to be sure that nobody thinks that I'm sure of that. So that is something we really have to pay attention to. So how do we time our societies, and how do we push forward to bring about certain things? The second, come on, oh, here it is. The second thing is we have two discourses that are actually a bit in contradiction. The one is, if you want success, you have to leave your comfort zone. So be radically innovative. Just try out whatever you can try out. Don't think too much, just go ahead. And the other discourse that says, could that be the end of life as we know it, like on this journal? So this prudence versus kind of entrepreneurship at any price is really there. And so in many ways, we have focused on a risk debate, but actually we can ask ourselves, is it only about risk? And what kind of risk are we speaking of? Is it not also about the question, where is the can-do and where is the should-do? And who should be involved in the should-do? And who can be involved in the can-dos? And I do think these two things need some kind of reflection on the way, like, how far do we go in science, and can we at all, if we go far in science, stop that by any means? And that's a big debate about if we open up certain possibilities, how far can that go? So where do these thoughts take me to? We live at a time of emergence. And you hear a lot about emerging technologies, emerging sciences. So we live in this idea that new has to come continuously up and can show disruptive qualities, sometimes disruption being a very positive thing, so the precursor to innovation, and sometimes disruption kind of questions social order. And so the question is like, which kinds of disruptions do we support? And we live at a time where standing still means falling behind, in the sense this idea that we cannot stop and think. So the idea like that was in 75, sorry, in Asilomar, that you say, let's wait for 2 years. This is just not an imaginable option to anybody anymore. And that's something we have to think about, why these things disappear as options. So while we need to engage in anticipation, that is part of our responsibility. We also need to be aware that we have actually no capacity of prediction. And I mean outside the lab, and outside the well-designed experiments, and outside our test animals, and outside our all these wonderfully controlled environments we produce knowledge in. We have no capacity of prediction, of clearly shaping, or even of anticipatory assessment. In that sense, all we can do is to think about the plausible possible. That's what we can do. And the outcome, also in that sense, always remains open, and therefore I think the notion of the experiment is much more adequate than anything else, because it reminds us that we are in a mode of self-experimentation, and that's how our society works. Now, what does that mean in terms of responsible research and innovation, and what does that mean for researchers? I do think while we should be prudent about the kinds of futures we project and we circulate, and maybe be more reflexive about all these anticipatory talk we produce, we need to develop future visions, because only through them we can think about what a logic of care, so to accompany these changes, what that could mean, so to keep rethinking science-society relation as we advance in our knowledge, and not to do that as a one-stop go. So this needs to be part of a knowledge production enterprise to kind of continuously kind of become a reflexive self. In that sense, approaching anticipation allows to embrace a precautionary approach, which is sensitive to new orders that are brought about, so to new classifications or new ways of thinking the world, but also attentive to past experiences. Now, RRI is always linked to this discourse on democracy, and I would like to invite you as a last thought to think about what is democracy when we say, oh, it's about democratizing knowledge. And I really like very much Yaron Ezrahi's definition of a democracy, which I pinned down. It's a lot to read, but I'll pick out the important ones. A democratic society can never be fully or at any moment a democracy. So he distinguishes between being democratic and being a democracy. And he says it's a precarious existence, it's fragile, and it depends on the mutual reinforcement of democratic ideas, political culture, political imaginations, institutions, and practices. A democracy, like any other political regime, must be imagined and performed, so done by multiple agencies in order to exist. Like a symphony, democracy has to be performed reasonably well in order to be realized as a political world. And so he has this idea that democracy is nothing like a perfect state, but it needs a necessary fiction, he underlines, and he says the necessary fiction is, for example, the reasonable citizen. So that the citizen can argue as a reasoned person, or the possibility that everybody has at least the potential to engage, etc. That's the necessary fiction for democracy to at all, in any form, to be real. Now, if we transpose that, we could read Ezrahi's notion of through the same way we could replace it by responsibility and say RRI, like any other valuation regime, like any other giving worth, must be imagined and performed by multiple agencies in order to exist. Like a symphony, RRI has to be performed reasonably well in order to be realized as part of a techno-social world. And it needs some fictions in order to work. And in that sense, we need to integrate different kinds of experiences and knowledges. We need the researchers as much as societal members, both from the scientific and the social realm actors, to engage with issues of anticipation and future making. And that's why I come up with the notion of collective experimentation, because the experiment cannot only be defined, so the protocol of this experiment cannot only be defined by science, but needs to be brought up by, and as with every experiment, it changes in the course. I don't need to have to tell that to this audience, that things when they start up are not the same than when they go down the road and end. So this demands a rethinking of the relation between societal values and scientific evaluation practices. So what we value as citizens and what researchers value in a research system. Thanks a lot.
Thank you very much, Ulrike, for a very important talk that raised many relevant topics. I think we can take time for one short question. In the back.
Just a slightly naive question about this collective experimentation. I don't quite understand it. So when I normally think of an experiment, this is something I'm doing. I can look at the outcome, and then depending on the outcome, I can say I'll do something with it, or I can forget about it, and there are no further consequences. But the sort of societal experimentation, so I don't see these undoing, so that you are without consequence if it goes wrong. Can you further explain that? Because I didn't understand that. Thank you.
Now, an experimentation, of course, from my view, doesn't start when you do the experiment. There have been protocols defined and ways to think what is a reasonable way you spend your money and time on. So the experiment does not start when you pour something from A to B, or when you bring in your animals, or when you do whatever you do in the kind of research. It starts much earlier. It starts when we fix rules for experimentation, when we think about what is a good experiment and things like that. And in the same way, I think collective experimentation needs to needs to include societal actors in making the protocols. So and a protocol means looking for safety, looking for other things. So there is a lot of more engaged than in just doing the experiment at the end So that's how I understand the experiment, in an extended way. And you do the same, at least the many researchers I've been working with for over the last 10 years, they have the same kinds of thoughts. When I ask them, so why do you do it like that? How do you imagine that your experiment can work like that? He comes up with a flow of things he has been thinking about before it just boils down to writing up, I'm doing it to find out X, Y, Z. So that's what I mean by collective experimentation. The collective is then not the scientific community that defines certain rules for experimentation and what good experimentation is and what kind of resources you're allowed, animals, cells, whatever. And in the same way, one would need to have more societal engagement if this becomes an experiment.
Thank you. We don't have so much time right now, but I really would like to encourage you here in the room to use the time in the next 2 days to also talk with Ulrike in the breaks and ask her the questions you have about RRI. Thank you very much.
I surely have a lot of questions what you're doing.
Yeah.
Thank you.
Ulrike, I would like to thank you.
Ah, sorry. Thank you.
We're now proceeding to the last talk in this session on realizing the future together. Students and young talents are very important for DigitalLife, and we have our own DigitalLife research school, as you know. So it's a very big pleasure for me to now welcome one of the students from DigitalLife on the scene. This is Svenn-Arne, who will talk about tools for experimental data management, and he's affiliated with the DigiBrain project.
Thank you very much. Hi, everyone. So my name is Svenn-Arne. I'm a computational neuroscientist, and I will present this project Xpipe with you together with my good friend and colleague Milad, who's a bit shy at the moment. No, I'm just kidding. He is just getting his microphone ready so that he can join me on stage. But Xpipe is a project that we started in our lab to ease and simplify and organize the path from experiment, it being in the lab or numerically, to analysis. And one of the complications that we found in the lab is that we work with many types of data, and this is also the case with many others in the field. We have, for instance, electrophysiological recordings, which is one-dimensional data. We have behavioral recordings, which typically comes in the form of videos or 2D positions of tracking. We also have microscopy data, which can be really large. These files from single experiments can be up to gigabytes in size. And we also, of course, have static microscopy images. So typical solutions to solving this storage of data and data management tend to end up in two extremes of the spectrum. And one extreme is having a too flexible system where you just store all the files in the file system in some kind of organization that has been provided by the person doing it. And this typically becomes very messy. But yes, I guess you have all seen this, right? In the lab, different team members do it in different ways, and it's kind of hard to pick up the data afterwards. And that's probably the most important point, that transferring the skills and the knowledge to new team members is really hard. And I guess in this case, it's long overdue to do the transfer. But still, this is the way you have to solve it if a new PhD student comes into a lab with data organized in this way. It's basically an interview setting where the new PhD student has to interview an older PhD student about whatever this strange, obscure file name actually means that somehow was a system to the original team member. In the other end of the spectrum, you have databases. SQL is a structured query language typically used to get data out of databases. And the problem with going all in with the database format, even though it's very nice and organized and rigid, is that data of large sizes cannot really be stored into the database unless it's a very flexible database system. So typically you would have to have some system on the side as well to store the data itself. In addition, typically in relational databases, you would have to beforehand define how the data is to be stored. So you, or we would in our case, have to define today how we would store the results of experiments that we're going to do in months or even years ahead from now. And that's not scalable as well. And here comes Milad.
Okay, so we have seen that a too flexible solution is not optimal, and neither is a too rigid solution. So what we did with our solution, surprise, surprise, was to place it somewhere in between. So with our solution, the user is able to define new templates with metadata when they start on a new project. So we call them templates, and these are based on NoSQL, which gives us the option to store the metadata in a systematically way without making any assumptions about how the future experiments are going to be. Specifically, we have designed this browser, which we call Xpipe browser, where the user can register their experiments and attach different templates containing metadata to these experiments. We will come back to this later in our presentation when we go through a use case, but for now this is our solution for storing the metadata. So the next step is, how are we going to store the actual data, the raw data? And when it comes to that, there are two questions that needs to be addressed. One is, what kind of structure and hierarchy are we going to use for storing the data? Basically, where should we put the different types of data? And the second question is, what kind of file format are we going to use for that? So in the neuroscience community, people have tried to standardize and find solutions for these questions. And they have developed a very nice recipe, basically showing what kind of data that should be put where, that people can follow. And regarding the second question, they have chosen to use the HDF5 as file format. So HDF5 is a format developed by NASA. It's heavily used in many different fields, and the core concept is that you have one single file consisting of groups, data sets, and you also have attributes that you can attach to the groups and data sets. And this is a very nice structure when you want to structure your data, and it fits very well to the recipe that these groups in neuroscience have developed. But unfortunately, there are some issues with this format. The most important one is that it's not flexible enough, at least not for the needs that we have. And you have also issues with data corruption. Let's say that you want to read your data and you have this one single file. If something goes wrong, all your data is gone, basically. And this is critical. And there are also issues with performance and prioritizations. So we started to think and look for other options. So we thought, why not take these very core concepts of HDF5 with groups and data sets and make it simpler, make it more lightweight. And this is exactly what we have done. We have developed this XDIR format, or experiment directory structure, which is really not a new file format. I would say it's file format less, because we are using folders, text files, and binary files. So here you can see an overview of an XDIR folder. It consists of other folders that can be datasets or groups. And datasets have binary files, for example, and these are NumPy files, which again are very well established, standard format with many nice features that we can reuse. And when it comes to the attributes, we can save them as simple text files together with the groups and datasets. So since these are basically folders, you can navigate through them using your file browser, and you can put any kind of data inside these datasets. As we mentioned, we have many different types of data in neuroscience, and we don't know what kind of data we are going to have in, let's say, 10 years or 20 years. But since these are folders, we can put anything in them. We have also developed this XDIR browser to make it simpler for the users to navigate through their data You can basically open a file and look at the data, the attributes, the units, and so on.
So there are many solutions like Xpipe out there, and I bet many of you have already seen some examples. What we try to do differently than many others is that we try to have an overarching design principle that everything should be simpler rather than to have a one solution fits all. So think of Xpipe more as a piece in the puzzle rather than the whole picture itself. So as mentioned, we had Xdir for the data, lightweight, and also Xpipe for the metadata, also very lightweight and intended to be flexible and future-proof. So let us just briefly go through a small use case or how we imagine people using this for storing the metadata. And I apologize for the small font here. I'll try to explain the different elements. This is the Xpipe browser. And what you see here are different experiments stored in a project. So each experiment has only a limited amount of information attached to it in itself. The idea is that you can expand upon information that you want to store in the experiment with these templates that we talked about, which are defined down here. And these templates you can create yourself, but we also intend to make a system where you can share them with others in the community. And they're basically just, basically just definitions for how the metadata should be organized for different types of experiments. So the idea is that when you start a new project in the lab, you define the different templates that you think you need, you can evolve them as you go, and create them, attach them to the project, and they will then be available to be added to each experiment along the way. So in this case, this is one of those templates that has been filled out. It's the box size in a behavioral experiment. And it is a value, 2 by 2 dimensions, 100 times 100 centimeters. And one of the benefits that we saw when we designed this is that these templates are basically copy-pasted into the experiment. And this is very different from what you would have if you had a database with tables that define how everything should be organized. Because in a database with columns that are defined beforehand, if you want to change the structure, you will also change the structure retroactively for every experiment that has been done. So say that you start storing your box size in meters instead of centimeters, then suddenly all the old data is not valid anymore, and you would have to go back and change it. So the idea here is that by doing it more flexibly, we actually leave the experiments as they were when they were registered, rather than opening up to being able to change them like we would do in a database.
So we like lightweight solutions, and we have tried to make Xpipe lightweight. And the reason for that is that it gives us flexibility. For example, we know that people are using a lot of different packages when they do their analysis. It can be code developed by some lab member, maybe not so well documented. And you have also packages that are well established, well documented. And people are using all of them. And we have tried to make Xpipe flexible and lightweight so that we don't make any requirement on the work frame that these packages have to adapt to. You can basically use Xpipe to get your data, and you are ready to go. And you can use the tools that your favorite tools, basically. So we usually use Jupyter Notebook. We get the data, we use the different packages to do the analysis, and when we are happy with the figures, then we start to think about publications. And this concludes, in a way, the platform that we have developed, and we hope that it can ease the road from experiments to publications. Thank you.
Thank you very much, Svenn-Arne and Milad. I'm sure there are many people in the room right now who are jealous that you're not their PhD students. That was very impressive. There will be time for discussions with them in the break, but is there one pressing question for the moment?
Can the data be manipulated or changed? Yes.
Yes.
Definitely. So in other words, it cannot be used in a digital laptop. No,
Sorry?
not right out of the box as it is right now. It's
intended to be used together with the regular
It's
lessons.
on.
There are many questions here. I'm not sure how much time we have, and we'll take one more.
Thank you for the presentation. I wonder, now you say that the information can be used in publications. If someone reading the paper, how would they access the data?
How they would access the data?
Yes.
Yeah. That's, as of now, not part of the project itself, but it's something that we want to aim for in the future, that we want to extend it so that we can easily make the data available for others as well if people want to do that. And we're very open to adding that as a solution because we also care a lot about the open data and open access. Okay.
Thank you very much. A little present from the organizers.
Thank you.